So, if you're thinking about assigning a calculator for your math class, then I want to talk to you. I want to show you that there is really a good free alternative to using a standard calculator in a math class. Any math class, in fact. So let's take a look what this thing is. First, to get us going, I'm going to recommend that you look at a video demonstrating the performance of matrix calculations on a TI-84 calculator. And I'm not going to show you this video, I'll just let you do it. Okay, so I'm using SageMath 9.7. I've got it installed on my computer, and I'm running it in the Jupyter Notebook. But you don't have to do that. You can use this the same commands in the Sage Math cell, which is right here. And I'll show you in a few minutes how to use the math cell. Then I'm just walking through the commands that, that were in the video. I'm going to replicate them exactly. And the first thing is to create a matrix called A with these numbers in it. So you have a parentheses for the function call. Then you have the outer square brackets, which group things together as a matrix. Then you have two sets of inner square brackets, one for the first row, one for the second row, and within the rows, the numbers are just separated by commas. So I did that, and then I printed the matrix, and that's what I got. I could do it a different way. The different way is to use the same matrix function, but this time the first two arguments are the number of rows, number of columns in the matrix. And then you enter all four numbers in the 2x2 matrix in one list. So I called that matrix another A. Then I created a second matrix called B, 1, 2, 3, 4, very unimaginative. The reason why I created B is I wanted to show you how to do matrix operations in Sage Math. So I create a matrix C, which is the sum of the matrices A and B, and it's a very simple command, C equal A plus B. And I multiply two matrices. I'll call the product D. D is A times B, the symbol for multiplication. As you might have suspected, it's just an asterisk. I can get the determinant. The determinant is a function in Sage Math. So det of A will give me the determinant of A, which is minus 2. The inverse, the notation for inverse is to the minus 1 power. And there it is, A to the minus 1 power. And you'll recognize that this is the same matrix that the fellow got in the video demonstrating the TI-84. I can verify the inverse. I multiply the matrix A by the matrix A inverse, and I get the 2x2 identity matrix. And then I'm going to get into the system of three equations and three unknowns that the author of the video solved. And you first create the A matrix, and there is the A matrix, the same one that he did. I printed it out. Then I have the B matrix, or the vector B. It's a 3-row, 1-column matrix, 11, 10, 8. So here's A, and here's B. Then I'm going to augment A with B, and I call it A underscore aug. And this time I use a method, A dot augment B, and there is A aug, and you can see that what I've got is the B matrix added as the fourth column for the A matrix. I'm going to get the row reduced echelon form, and again it's I call the result solutions. So I take the matrix A underscore aug and I use the method .rref, row reduced echelon form, and I see that the solution value for x is 4, for y is 1, and for z is 0. I get the same thing using the matrix inversion, A inverse times B, and I get the 4, 1, and 0. So that's it. So these are really easy commands to write. I would suggest that they are much more natural than following the commands to get the same work done on a pocket calculator.